Welcome dear learners in Introduction to Electric Vehicle and Hybrid Electric Vehicle in week 6, and today we will discuss about the ultracapacitors and its application in EV. So in the previous lecture we have seen the fundamental of battery management system, and additionally we have seen the functions of battery management system, and we have also covered the various types of battery management system, and we have seen the different topologies or structures of the BMS, and we have seen the various research trends in the BMS domain. So in this particular lecture we will see the basics of the ultracapacitors, how it works, what are the different ultracapacitors are available, and how we can utilize the ultracapacitor for EV application and for the UPS application and for the renewable energy sources. So we will see one by one. So let us first understand what is ultracapacitor. Ultracapacitors are also known as supercapacitors, and the supercapacitors are energy storage devices that combines the high energy storage capability of battery with the high power delivery capability of the capacitors. If you see this particular figure where the power density are compared with the energy density of different what we call the different types of capacitors, like conventional capacitor, conventional electrolytic capacitor, supercapacitor, battery and fuel cell. As you can see, the supercapacitors are lies between conventional capacitors and battery. So basically these supercapacitors are bridging the gap between conventional capacitor and the batteries. So in the supercapacitor we are having the two conducting electrodes which is separated by a insulating dielectric material which allows them to store or release the energy quickly. So basically supercapacitors are capacitor which can release or store the energy quickly. So whenever sudden energy requirement comes into picture, then supercapacitor will be a preferable choice. And moreover, this ultracapacitor have low equivalent series resistance, more commonly it is known as ESR, allowing them to deliver and absorb high current. So whenever very high current is required for a very small period of time, then supercapacitor is the most preferable choice in that particular application. Let us understand how the supercapacitor works. As you can see in the picture, the second picture indicates the what we call the cut view of supercapacitor. As you can see, we are having the porous paper separator which is in between the two different electrodes, okay, and it is a what we call the capacitor body, and at the top we are having the connecting terminals. So this is the typical structure of a supercapacitor. So basically supercapacitor comprise two porous electrode, a membrane which separate positive and negative electrodes called as separator. Electrodes are electrically connected with ionic liquid called electrolyte. When voltage is applied across the electrode, the negative ions get attracted to the positive charged plate and positive ions are attracted by a negative charged plate. It eventually leads to a thin coating of ion deposited in the inner surface of the plate, which no doubt decreases the what we call the distance between two plates, and because of that the overall capacitance of a ultracapacitor is very high. So supercapacitors have metal plates covered with a porous material or nanomaterial in the form of typical carbon or activated charcoal. Static electricity is used in those capacitors to store energy. Those capacitors produce positive and negative charged ion between two plates in electrolytic solution. This is because of presence of applied voltage. One plate develops the positive charge and another plate develops the negative charge. The deposition of ions on the plate results in the production of electrostatic double layer. This layer is similar to the one connecting capacitor in series, and distance between both the capacitor are very thin. As a result, each charge possesses a high capacitance and the area of electrodes is high. So let us see what are the different type of ultracapacitors are available. The first type of capacitors are known as EDLC, and in the EDLC ultracapacitor, there are three types of ELDC capacitors. The first one is known as activated carbon, the second one is known as carbon aerogel, and next one is known as carbon nanotubes. The second one is the pseudo capacitor. In the pseudo capacitor, conducting polymers and the metal oxides are two types of pseudo capacitors. And if we consider the third classification, which is known as hybrid capacitor. So basically hybrid ultracapacitors combines the properties of ELDC and pseudo capacitor in order to make the advantages of both type of capacitor. And in the hybrid capacitor classification, we are having three types of ultracapacitor. The first one is known as composite hybrid ultracapacitor. The next one is known as battery type hybrid ultracapacitor, and third one is known as asymmetric liquid type hybrid ultracapacitor. So depending upon the different application, those ultracapacitors are used. So let us understand what are the different merits are associated with supercapacitors. Supercapacitors have high energy storage capacity compared to battery and conventional electrolytic capacitors. This particular property makes a suitable choice in the EV application and some other application like what we call in renewable application as well. This is because they used activated carbon material to that increase their capacitance value. The shelf life of supercapacitor is longer than battery. This is because battery degrades early due to energy storage and it's released via chemical reaction inside the electrode material. Additionally, supercapacitor can provide large power burst and high power density for a short period. And those capacitors can take short time to recharge and supply frequently high power demand peaks. So mostly these ultracapacitors are used for a short period in a peak hours. Apart from advantages, there are certain disadvantages as well. So no doubt the supercapacitor are costly. If we compare the cost of supercapacitor with a conventional electrolytic capacitor and compared with the what we call the multi-layer ceramic capacitors. Next one is the self-discharge rate of the supercapacitor are high. So if you compare the self-discharge rate with a conventional electrolytic capacitor, then no doubt it is having the higher rate of self-discharge. And if we compare the voltage limit, then in supercapacitor we are having the voltage limit. So therefore, if we require a higher voltage, then we need to connect the different supercapacitor in a series manner so that we can achieve the desired voltage. The next disadvantage with the supercapacitor is the linear voltage discharge, which makes it impossible to use the entire energy spectrum of the supercapacitors. So let us see the different application associated with the supercapacitor. So supercapacitor are used in the electric vehicle. Also, this can be used in the electric buses to provide a high energy whenever acceleration is required. Also, this can be used in the hybrid renewable energy systems where solar or wind are applicable. So no doubt the supercapacitor will reduce the stress on the battery whenever it is used in the renewable energy systems. If we talk about its supercapacitor application in consumer electronics, then it is extensively used in the camera flash, and also it can be used for the IoT devices and for what we call the DSLR camera or normal digital camera. It can be used for the flash. So let us see the difference between conventional capacitor and the supercapacitor. If we consider the working principle, the electrolytic capacitors store the charges electrically. However, the supercapacitor stored charge electrostatically. So that is why supercapacitor having the more capacitance value compared to the your conventional capacitor. If we talk about the dielectric material, so in the case of electrolytic capacitor, air, ceramic and plastic films are more common, whereas in supercapacitor, metal oxide, carbon aerogel and activated carbon are more common dielectric materials. And if we see the capacitance value, then electrolytic capacitors or MLCC capacitors are having a few farads. More commonly, it comes with the microfarad range capacitance value. However, your supercapacitor having available supercapacitor value is up to thousands of farads. So no doubt the capacitance value is very high in case of supercapacitor. If we talk about the energy density, then in the case of electrolytic capacitor, we are having the less than 1 Ah per kg, whereas if we talk about supercapacitor, we are having the 5 to 10 watt hour per kg. And in the similar manner, if we compare the power density, then in the case of electrolytic capacitor, we are having around 100 watt per kg, whereas in the case of supercapacitor, the power density is around 10 kilowatt per kg. So very huge if you compare those power density and energy density. And if we see the charge time, electrolytic capacitor is required the time to charge is in between second to hour, whereas supercapacitor charged within a minute. And in the similar manner, if we compare the discharge rate, electrolytic capacitor is very long, whereas supercapacitor will take a few minutes to discharge completely. So let us see the application of ultracapacitor in the case of standalone renewable energy system. As you can see in this particular figure, where there are two buses, DC bus and AC bus. In the DC bus, the energy sources are connected, whereas in the AC bus, the load are connected. So in the DC bus, we are having the PV array, which provides the DC power supply, and we are having the wind turbine as well, battery and supercapacitor as well. So basically, battery and supercapacitors are energy storing element which supplies the power during the what we call whenever this PV and wind is not available to give the power to the DC bus. At that time, battery and supercapacitor will come into picture. In general, battery is more dominating with respect to the power delivery. However, whenever any sudden requirement of the power come into picture, then supercapacitor will actively discharged through a DC bus, so that it can accommodate the required power, required energy of the bus. So whenever such kind of system is so whenever a quick power is required, then this supercapacitor will discharge through this DC bus, which can go through an inverter to the load. So this is the typical application of a supercapacitor in the renewable energy systems. So let us understand how these supercapacitors are useful in the case of electric vehicle. So in the electric vehicle as well, the primary power supply is the battery. So battery packs are giving the power to your drive 10. However, whenever a very quick power requirement is needed, at that time the battery is not able to give such kind of high power. At that time, your ultracapacitor is available to release quickly, so that it can accommodate the quick energy requirement of the electric motor. So both this battery pack and ultracapacitors are connected to this particular PMC block, and where the inverter electric motor are connected together, so that it can take the power from the battery pack as well as from the ultracapacitor whenever it is needed. So it is having a great application in the EV. Nowadays, many researchers have used this ultracapacitor along with the battery packs. No doubt in the future, the battery packs and ultracapacitor will also accommodate of what we call the fuel cell, so that we can increase the what we call the total range of an electric vehicle. So in the heavy capacity EV, for like if we consider the electric bus and electric truck, then no doubt such kind of system will be more preferable in the case of hybrid system, where battery and ultracapacitor and fuel cell are used. So let us understand who are the manufacturer of ultracapacitor. So if you see the different website like Mauser and other DZKey, then these are the main manufacturer of the what we call the ultracapacitor, the Abracon, Camet, Camcap, Kyocera, Maxwell, Eaton, Nichicon, Wood Electronics. So these are the some industry top manufacturer of the ultracapacitors. So those are having a good market visibility. So let us see the different types of supercapacitor based on their construction. So we are having the coin type ultracapacitor, we are having the winding type ultracapacitor, also we are having the full welding ultracapacitor, combined type ultracapacitor, module type capacitor, and high temperature ultracapacitor in some of the critical application where high temperature is required. At those application we generally prefer the high temperature ultracapacitor, and similarly we have a hybrid capacitor series. So I have taken from CAMCAP, this particular reference I have taken from the CAMCAP. As you can see, this is the coin type ultracapacitor, and it is a SE series ultracapacitor, and its rated voltage is 5.5. So no doubt whenever you require more voltage, you need to connect those coin ultracapacitor in a series manner. Its range is about 0.1 farad to 1.5 farad, and its operating temperature is minus 25 degrees to 70 degrees Celsius, and its life cycle is about 1000 hours. So let us see the next type of ultracapacitor, that is a winding type ultracapacitor, and we are having two series, HE series and HP series, both having the rated voltage capacity of 2.7 volt. It can sustain the surge voltage of 2.85 voltage, and the first series is known as HE2R7, which comes in the capacity of 0.35 farad to 25 farad, whereas this HP2R7 series come with the capacity of 0.1 farad to 3000 farad. So it can be typically used for the EV application, and its life cycle is about 1000 cycle. So in this particular series we are having the next series, the combined type supercapacitor. So in this combined type supercapacitor we are having two types of capacitor. The first series is 5R5, which having the rated voltage of 5.5. So it is having more voltage compared to the coin one. So it is the size of the combined type supercapacitor is little bit higher in the case of if we compare this one with the help with coin type supercapacitor, and its rated voltage is around 5.5 volt, and it can sustain the surge voltage of 5.8, and its capacity in the range of 0.33 farad to 7.5 farad, and no doubt its operating temperature is minus 25 degrees Celsius to 70 degrees Celsius. It is also come with the life cycle of 1000 hours. So it is a content for slide number 4. Let us compare the ultracapacitor with batteries. Batteries and ultracapacitors shares many similarities, such as having a same electrochemical structure involving electrodes and electrolytic solution. However, the main difference is that in a battery, chemical reaction takes place in the solution between electrodes, whereas in ultracapacitor there is only electron movement. This is the basic difference between battery and ultracapacitor. Due to the way that they design, the instant where the lots of energy needs to be delivered quickly can significantly damage a battery and its lifespan. In comparison, ultracapacitors specialize in delivering energy rapidly but can't store much energy as a battery. Simply put, ultracapacitor have a higher power density than battery but lower energy density in comparison. In many use cases, batteries and ultracapacitors will be used together to mitigate each other's weaknesses. Okay, this is the content for slide number 12. So let us understand how ultracapacitors can be utilized for the standalone renewable energy systems. It is very useful because, as we all know, in all the renewable energy sources are intermittent in nature, and also it is a weather dependent, and because of that we will not get the stable output, and we required a high power density sources like ultracapacitors. So ultracapacitors are transforming the renewable energy market by allowing the efficient capture and utilization of excess energy. Supercapacitors can store excess energy generated by renewable energy sources during the periods of high production, such as in the daytimes in the case of solar photovoltaic, and it can release it during the low production time, providing the steady and stable energy supply to the grid. So during the peak times, the ultracapacitor can release the power, and during the off-peak time it can store from the renewable energy sources. Green energy generation is weather dependent, as I already mentioned, leading to the power output fluctuation, and short-term variability in radiance adversely affect the system energy output and reliability as well. Standalone operation of a generating system necessarily storage energy units that manages the transient loading and effectively share the power between load and energy storage. In this particular diagram, it is illustrated that this particular supercapacitor is utilized for the short-term energy storage solution. Okay, by effectively sharing the power, rapidly charged and discharged of ultracapacitor which results in the voltage restoration under the transient condition. Okay, and by integrating the supercapacitors PV systems, it will manage the power oscillation when there is a sudden change in the renewable energy sources output. Okay, now we will see how these ultracapacitors are utilized in the electric vehicle systems. An ultracapacitor is a device that store and provide energy on DC bus in a particular situation, including as acceleration and the regenerative braking time. Okay, ultracapacitor is used to avoid the direct inrush loading on the battery, which the electric drive system can cause. The energy from the ultracapacitor is injected to a DC bus in complement to battery. The charge discharge of ultracapacitor is done through the bidirectional DC-DC buck boost converter. The use of ultracapacitor to offload the high energy demand from the battery and store the energy recovered during the regenerative braking helps to improve the vehicle's life as well as the per charge range. Also increase the per charge range of the vehicle. The stored energy in the ultracapacitor can be obtained from the battery at the starting, and ultracapacitor can charge at the same time of charging. Let us see what are the advantages of using the ultracapacitor in the EV. To keep battery in the safe limit, ultracapacitor can keep the batteries within the safe resistive heating limits, which can extend the battery life. Regenerative braking, ultracapacitor can recapture the energy during the regenerative braking of EV. Power boosting, ultracapacitor can provide power boost during the acceleration. So dear learner, now we can see how we can select the different types of supercapacitors available in the market. So there are basically two different websites which are exclusively used for the component selections. The first one is the DZKey and the second one is the Mouser. So mostly these two websites are commonly used by the different manufacturers and R&D teams. So let us see the one by one. So first we will see how we can search the different components. So in the DZKey, in the search box, you just type the supercapacitor and search. So depending upon the availability, you will see there are multiple supercapacitors are shown here. So select the first one, which is EDLC. It is a double layer capacitor. So as you can see, the first option is the manufacturer. So these are the list of the manufacturers. We are having the different manufacturers depending upon your application, and we are having the series. So there are multiple series of the supercapacitors are available. Okay, and we can see the packaging, which kind of packaging you want, the box packaging or like tray packaging, a tape reel, whatever you want you can select from here. And at the end we are having the what we call the capacitance value, different capacitance value. You can see here the values of the capacitance 0.082 this millifarad to how much 600 farad you will get the value of ultracapacitor. And here you can see the product status, like if it is active, then like only active part will be shown in this particular list, and depending upon your requirement, mostly active part is required. Okay, so just select the active part and apply. Okay, and apply. You will get all kind of ultracapacitor here only. Okay, from the small what we call the coin ultracapacitor to the big size ultracapacitor, which is used in the renewable energies systems. So see, okay, and you can also compare the cost and their available stock. You can compare from here. So in this way you can select your component in this particular DC key. You can select other part as well, like MOSFET, IGBT and other part as well. And similarly we are having the this Mauser electronics as well. You can also select here. Okay, so I am searching the supercapacitor here. As you can see, you can filter out by different manufacturers depending upon the capacitance value, voltage rating, terminal style, like it is a SMD one or the leaded one, then the lead spacing, diameter, length and width. So according to your specification you can select the different what we call the filter, your operating range. And here compared to DC key, we are having the more detail, even we are having the life cycle as well, how much charge and discharge life cycle we are having. Okay, so we can select from here. And also from the Mauser we will get the ESD, you can get the ECAD file as well. So ECAD file will be useful whenever you are designing the PCB. So for the PCB designing you required such kind of files, so directly you can get from the Mauser. So those websites are very useful for the selection of components. So in this particular lecture we have seen the fundamental of ultracapacitors and how it works, and also we have seen the different merits and demerits associated with ultracapacitors and how these ultracapacitors are applicable for the renewable application and for the EV application. We have seen in this particular lecture. So in the next lecture we will see how the flywheel and fuel cell technologies are work, and we will see how these flywheel and fuel cell technologies will be applicable for EV application. So these are the references that I have taken for fuels that I have taken for this particular lecture. You can go through it for more details. Thank you.